Okay, so I would like to do 10.2 number 39, where I would like to calculate the inverse function for k of x is 3 minus the square root of x over the square root of x plus 2. Okay, thoughts?
My thoughts I just had is that because they're square rooted, it makes me feel like they're going to have plus or minuses, which makes me feel like it wouldn't pass the horizontal line test.
That is a really good thought, and unfortunately a little off base.
Okay.
If there were squares,
then it would be.
then I would expect, as I solve, to have to invert squaring, right?
Right. Right.
So this is a weird thing. Squaring doesn't have an inverse,
That's where roots.
but square rooting does.
I think that makes sense.
You guys see that?
Plus you.
It's not a two-sided square root is not a good inverse for x squared, right? You guys see that? Like, there's this plus or minus business that shows up, that's problematic. X squared clearly doesn't pass the horizontal line test because it looks like it looks like this thing,
Yeah.
right? Like, really clearly hits twice for basically every horizontal line.
But the inverse of a square root being squaring does have an obvious, like,
Yeah, so let's settle that.
it doesn't have a plus or minus.
So if this is square root of x, right?
Yeah.
You guys with me on this part? Okay. If this is square root of x, this clearly passes the horizontal line test, right?
Mm-hmm.
And my thought is that an inverse would be x squared,
Yeah.
right? Like, if I called this s of x, then I would think that s inverse of x is x squared.
Yeah.
You guys see that?
Right. So it just goes.
Yeah, so there's this trick for calculating a picture of an inverse, right? You flip over the line y equals x.
Mm-hmm.
You guys remember that trick?
Yeah.
Okay, so if I do that trick to this, I would think my inverse looks like this guy, right?
Right.
But that's not x squared.
That's half of x squared.
That's half of x squared. So your s inverse of x is not really x squared, it's x squared restricted to the real numbers that are positive.
Okay. That makes sense. So that's what we'll have
What
to
if I
do.
restricted that to 0 to infinity? How about that? Is that better?
Okay.
Cool?
Yeah.
So this pair is an inverse.
Yeah.
A function and its inverse pair. And these are real inverses.
Okay.
But the full squaring function,
Is
that doesn't have a real inverse function.
Yeah.
You guys cool that?
Mm-hmm.
So my thought here is like, there are square roots.
That's okay.
I might be okay. So this one I think probably lends itself to the algebraic approach more than the bubble diagram approach.
Yeah. Yeah.
Okay, so let's try it. So how did the algebraic thing work again? Bailey, what was your trick?
Oh, well, I said y equal to the x's and I solved for y. And just
Set y equal to those?
mm-hmm.
Okay, so you set y equals 3 minus the square root of x over the square root of x plus 2.
Mm-hmm.
And then you do something wild like, yeah, get the bottom out of there, multiply by the square root of x plus 2. So you get y times the square root of x plus 2 equals 3 minus the square root of x. And then what am I solving for?
It's only x.
Or no, you're solving for x.
Yeah, I think I want to solve for x, right? Because I already had it solved for y. So I just have to not lose track of what I'm solving for.
Solve for x.
So because I'm prone to doing that, I'm just going to write over here. Solve for x, so that I remember what I'm solving for. Okay, so I want the x's by themselves, right?
Yeah.
You guys see that? So
Distribute the y.
distribute the y through. So you get y times the square root of x plus 2y is 3 minus the square root of x. Then what?
Subtract 3.
So let's see. I want to get the x things on one side and the y things on the other. Which way do you want to go?
X is that one.
X is this way?
Yeah.
Cool.
So I think
Does it matter?
No.
No. So I want to subtract y times the square root of x. So I got 2y is 3 minus the square root of x minus y times the square root of x. Okay, then what? Subtract 3. So I got minus 3 plus 2y is minus the square root of x minus y square root of x.
And divide by y.
No.
I take out the square root of x's.
Factor the square root of x's out of that stuff. That's a good idea. Why do I think factoring is a better idea than whatever else?
Is it isolates? Yeah, isolates.
Yeah, because I want 1x by itself, right? What am I left with in there?
Negative 1 minus y.
Negative 1 minus y. And on the other side here, I got a 2y minus 3.
Yeah. And
Then what?
Divide by negative 1 minus y.
Multiplied by 1, negative 1 over 1 plus y. However you choose to do that. So I got 3 minus 2y over 1 plus y is the square root of x.
Yeah. That's the square both sides.
Okay, so then I square both sides. So I got x is all of 3 minus 2y over 1 plus y squared.
Yep.
Okay?
So that's your inverse function.
Wait,
No.
Bailey, why am I confused?
Well, now you go y equals, and then you put the x's back where the y's
K inverse
are.
of
Or k
x.
inverse of x.
Yeah, so now at this point, right, this is really how you go from a y and get back to the x, right? You guys see that? So maybe the best labeling for this thing would be to say that this is k inverse of y. See that?
Care if it was like that?
No, not at all. Your book is definitely going to say that the appropriate answer is k inverse of x is 3 minus 2x over 1 plus x all squared. So my question to you is now, philosophically, why does your book do that instead of leaving the y's in there?
Because it's
If
really
you want
not.
the inverse of k of x, inverse of k of x.
Yeah. X is the input that you're trying to inverse, not y.
If you wanted to graph it.
Yeah, it's more like because if you want to graph it.
Right.
You guys see that?
Yep.
So really what I've lied to you just slightly with the bubble diagram that I draw. Right, because I really like to draw this bubble diagram where we have k that does this thing. Right? Well, oftentimes this blob and this blob are both numbers, right? Like this is the real numbers and that's also the real numbers. So maybe it would be kind of reasonable for me to draw my bubble diagram like this, right? Like k takes numbers and makes them into different numbers, right? So it just kind of rearranges this thing. And if I wanted to back out of that, I'd have to do something like this, right? This picture is just confusing, which is the reason I don't draw
I
it.
guess the way I interpret, the way I interpret the other picture is that those blobs are the same. It's like the same mass conglomeration.
So the reason that they want you to have k inverse of x is because they want to be able to graph those both on an x-y axis where x is the input and y is the output. You guys see that? If you graphed this function and the other one, they would be the same. You can see that?
What did you just say?
If you graphed this function,
Yeah, and
k inverse of y, and if you graphed k of x, this using x as the input and y as the output, and that using y as the input and x as the output, they would be the same friggin' picture. Because all a function is a relationship between inputs and outputs, right?
The same relationship.
And all an inverse function is the same relationship but phrased as between outputs and inputs. Right? So if you draw those if you graph those pictures, you get the same picture, which is why they want you to do this other thing. To highlight that they're actually different functions. You guys follow that?
So cool.
Okay.